Controlling your Arduino via Bluetooth adds an extra dimension to your electronics projects. But building an app, getting it talking to the Arduino, and getting everything working seems like a daunting task. But it really isn't. Let me show you how it's done. Hi, and welcome to Bytes and Bits. Adding Bluetooth to your Arduino project opens up a whole range of possibilities for being able to control it and to monitor what's happening in your project through an app on your phone or some other mobile device. First of all, obviously, you have to add a Bluetooth module to your Arduino, and either you'll have an Arduino with one built in, or you'll use something like an HC06 or HC05 module. And I've covered that in a previous video, which I'll put a link up in the corner here, or obviously down in the descriptions as well. And if you follow through those, you'll very quickly be able to add Bluetooth communications to your device. So after you've got a Bluetooth enabled Arduino, we then need to obviously work on creating an app on our mobile phone to be able to talk to that. Now that does sound like quite a large and difficult project, but actually it is made very, very easy by the clever people at MIT who have created something called the MIT App Inventor. And then that really is a sort of point and click style app creator. If you've used something like Scratch using sort of the block programming languages, it uses that as the programming interface, and then just a drag and drop sort of with icons for the actual controls in the app itself. So that's really what we're going to be looking through in this video, and showing you how we can then sort of devise our own communications protocol between our Arduino and our app, and then get the two things talking and controlling and monitoring what's going on. So let's get straight into it and see how we put it all together. Just before we get into the main content of the video, this turned out to be about an hour long in the end. So we do cover a lot of things, from how to design your own message protocol, and we look at things like data framing and error correction and so on. To make it a robust system, we look at how we can poll data to reduce our data transmission rates and stop message collisions and so on. And then, of course, we go through and there's a bit of a tutorial on how to use this App Inventor and how to add in the components and make that work using its block programming language. So there is actually a lot of content, and what I've done down in the description below, I've put in a couple of bookmarks to various parts of the video. So if there's something specifically that you want to go and have a look at, please do have a look there and jump straight to that part of the video. Otherwise, please do just enjoy going through the whole thing. I hope you enjoy it and I hope you find it useful. And as I say, it should cover enough to give you a good, robust serial communication link between your Arduino and an app running on a mobile device. So please do enjoy. Let's get into the video now. Let's start by taking a look at the actual project. So we have our Arduino Uno here with our Bluetooth module and an Adafruit NeoPixel strip. So there are 8 little RGB LEDs lined up in here. We then have our app running on my mobile phone. And again, this is programmed using this MIT App Inventor. So really what we can do here then is, at the moment our Bluetooth module isn't paired. So we need to be able to pair from our app. So here we can bring up a list of all the devices which are in the system, and you can see there that we can just select it on screen and we're now paired with our Bluetooth device. We're then going to use some user interface elements on the app which allow us to control the colors on our RGB LEDs. So you can see there I can then add in green and blue and red. So these elements then are being monitored by our app. The settings are being converted into color values, which are then being sent over a Bluetooth link down to our Arduino, and then it's translating them out to color values on our NeoPixels. We've also then got the return then, so that is from the app down to the Uno. We also then have a little heartbeat signal coming up here, so you can see it mimicking the LED, the little inbuilt LED down there, and that then is a number which is being sent out from the Arduino through Bluetooth up to our app, and our app's then translating it and putting it out here as the tick box going on and off, and of course then this little number changing here. So that shows all the elements that we need to get working. So our user interface, being able to read our controls on our user interface, put those into a message which we can send down to our Uno, having it translate them and understand them, take actions based on that, and then reporting information back up to us over our Bluetooth link. So let's look at this communication link then between our Arduino and our mobile phone app. So we know it's using Bluetooth to allow us to send data between these two devices. Let's look at the link then between the app and our Arduino. So using Bluetooth, we are able to create a serial stream of bytes of information. So in effect, any number between 0 and 255. And you can also then think of this as being a character stream. Again, using the sort of something like the ASCII table to convert bytes into characters. So to control our Arduino, we need to send a message with the various commands embedded in it from our app down to the Arduino. But as we're just simply sending a stream of character information, we need to be able to tell the Arduino where the messages start and where the messages finish, so that it can actually extract a full message in one go. And the problem here, of course, is if we were to lose communication partway through a message, or we were to start off and boot up in the middle of a message, then we don't want our Arduino getting locked up, waiting for this message to come through, which never has all of the information inside it. So we need to create data frames where we specifically specify the start of our data and the end of our data. And this then lets the Arduino synchronize itself with our command messages so that it can extract a full data block each time. These signals are just special characters or bytes which we send to mark these two positions. And if you have a look at an ASCII table, you'll find that the first 32 bytes of information are all of these special control codes. But you can really use anything you want, as long as it's not going to appear actually in your message. So for this, I'm going to sort of base our messages on sort of like a query string and a URL. So I'm going to use a question mark as my start of frame character, and then I'm just going to use a semicolon as the end of frame. The message itself will simply send down 3 color values for red, green and blue. So we'll format those as variable assignments separated by ampersand characters. And then if we add our start and end frame characters in, we get the full message that our app needs to send down to the Arduino. The software for this project can really be split up into 2 distinct parts. We have the app running on our phone, which we're going to program in this MIT App Inventor, and then the software that sits on the Arduino. And we then have this Bluetooth link in between the two, which as we've seen is just a serial data channel. So if we have a look at the Arduino code first, this is very much a development of our Bluetooth code from our previous videos. So if you haven't gone through those and learned how to set it up and get it talking to a serial terminal, then please do go through those, and I'll put the links down in the description down below. So we're setting up that. We've also then brought in this idea of this NeoPixel, and again that's just using one of the Adafruit libraries, and this line here sets it up, but that is a very simple system to use. Please do have a look at their documentation if you need to put your own NeoPixels on this. So we have a couple of function prototypes here, just to let C++ know that those functions exist lower down in the listing. This is our Bluetooth module setup here. In the actual setup function, again, we're just initializing both our Bluetooth serial channel, our NeoPixel strip, and our normal serial channel up to the Arduino IDE. So after that, then really we're coming into the application code for this. So we know that we're going to be parsing these messages as they come in over Bluetooth. So we need to just make a few constants here. So we're saying here, we're defining a constant to represent our start token and our end token, so the question mark and the semicolon. The delimiting character that's in between each of the variable assignments in the message, which is this is ampersand. I'm also then creating something called a character timeout. And really what this is going to do is going to help break our code out of any loops that it might get into as it receives data. So we know that we will not start buffering a message until we see the question mark. And we know that we will expect to see a semicolon to finish the message off. But if we're having unreliable a data stream coming through, say we're losing connection now and again, we might miss some of these tokens. So really what we're saying here is if the system starts buffering up a message and it's got to 20 characters without the message ending, then at that point it will be able to say something's gone wrong. Let's just exit out of here and see if we can pick up the next message data frame coming through and restart from there. So that just stops it locking up and getting held in some sort of loop that it can't get out of. We need to make a little flag which will tell us if we are waiting for the start of a message, or if we're not waiting for the start of a message, then we will be buffering a message. And of course we need a little string where we can start assembling the message as it comes in. One of the things with these serial channels, although the command on the app, or as we'll see in a second in our serial monitor, we might send the stream of data all in one go. That doesn't necessarily mean that the Arduino will pick it up all in one go. The data will stream in over the serial channel, so we will probably inside our loop, inside our Arduino code, be picking up individual characters as they arrive and are translated by the serial hardware. So you need to make sure that you allow for this, and your code, of course, then is able to do other things while it's waiting for individual characters to arrive. So we're going to use a buffering system where we will read what characters are available, put them into this buffer, and then once we finally get the message that the end token has arrived, at that point we'll know we have a full message and we can go off and process it then. This last little bit here, that's really to do with when we're going to be sending information back up to our Bluetooth link, so we're going to come back to that in a bit. So if we go to our actual main loop then, this first block is handling our received data from the Bluetooth link. So this will be the data coming down from our app. So we're going to receive that in character data. So we'll have a little variable here which we're going to use to receive the next block of data, or the next character in effect. The good thing about our Arduino is, of course, we have the serial link which communicates to the serial monitor in our IDE, and then we have this in this particular instance we're using the software serial module to handle our Bluetooth communication. Now those two use exactly the same methods to handle the way they work, so they are directly interchangeable. So what we could actually do here is we don't need to have the app available. What we can do is we can use our serial monitor to construct our messages and then send them down over our normal serial channel. So you can see here that this is actually using our normal serial channel to check if there's any data available. Once we get it running with the serial channel, we can simply replace this object with our Bluetooth serial channel, and then it will use exactly the same methods. So it should just drop in as a direct replacement and will then be ready to work with our Bluetooth, knowing that our system can handle these message frames, decoding the messages and getting that data onto our LEDs. So we're initially then going to write this. So this bit of test code here, as I say, we will use our normal PC to Arduino serial link as our message source. So we're saying here, if there are any characters available for us to read on our serial channel, then we come in and start handling those. So initially we are waiting for a start token to appear. So we're simply then assuming that the data we receive, we could be halfway through a message being sent. So we need to just sit in there waiting to see if we've actually got a start token, if we recognize that. So we're reading data in. So this serial.read, that just simply reads the next character in the data stream. So if that happens to be a start token, then we know we need to come out of here and start building up the message. Or we might get to the end of the available data, and at that point we just simply need to go back, and our system will eventually come back and loop through here, and we will come back into waiting for the start token. So when we drop out of this loop, either we have received a start token or there's no more data available. So if the last character we read was the start token, at that point we have now got to the start of a message. And we simply flag that by saying that we are no longer waiting for a start token. So when we come down here then, this is the block of software which handles assembling our message. So if we're not waiting for a start token, so in other words we've already seen a start token, and we have some data available, then we're going to read in the next available character and then append that to our message buffer. So that will start to build up the message inside this variable message buffer. And we carry on doing that, reading in and assembling our message until we either get an end token, and at that point we're going to do something about it, or we've read in all of the characters, at which point we let the software carry on and do its other stuff, and we will pop in again back in round here once there's more data available to see if they can then finish off the message. So if we do have the end token, at that point we now know we got the start token, we buffered all the data, we've now got the end token, so our message buffer now contains the full message. Now the way I've done it here, the message buffer will actually contain the full message plus the end token. So this line of code here just simply takes off that end token. So we're basically saying make our message buffer string equal to the string itself minus the last character. So at that point, our message buffer variable now contains our full command. So again, we're doing a bit of debugging here where we're sending that message up to our serial channel so we can see what's going on. And at that point, it's then going to call this function setLEDs and pass across our message buffer. So setLEDs is going to take that message and parse out the 3 red, green and blue values. So after that happens, we then clear our message buffer, and again, because we've just received our end token, we are now then waiting for another start message to become true. So if we've gone through here, we've received data, it wasn't the end token. This is where we're now checking if we've received more than our character timeout number of characters, then at that point our system's going to say something's gone wrong. It will report the error back up to our serial channel so we can see what's happened, clear our message buffer, and then say, just now wait until we get the next start character and ignore everything else after that. So that's our serial link, building up the message, making sure that it synchronizes itself with these data frames so that we end up having actual complete commands or complete messages being sent into our setLEDs function, which is going to then, of course, parse that and gather the information. So we can quickly take a look at the setLEDs function, which is down here. So really all it's doing is it's receiving our message, and then it's extracting out each of these variable assignments. So we know that the message is going to be in the format R equals a number and G equals a number and B equals a number. So it's very much built around that assumption, and very simply then just pulling out the R equals and then gathering the number, the G equals, gathering a number, and the B equals. So at the end of this, we will have 3 variables, our red, green, and blue. So the red, green, and blue, which will represent our pixel color components. And we simply then use this to set the color on our neopixels. Okay, so that's all that's handling there. So I'm not going to go into it in too much detail. Again, it's up to you as well. Depending on what your message format's going to be, you will need to write your own parsing functions to extract your data from that message. But the important bit is that we have a system of synchronizing our message buffering so that we can extract individual data frames and then supply that message to our parsing function in the knowledge that we've actually got a complete message. So if we upload that code up to our Arduino and then open up our serial monitor, we should now, if I just pull this across here, we should now be able to send commands down to our system. So if I send the start message character down to our Arduino, you can see there that it's picked that up and it's now saying that it has seen the start message, and it's now waiting for more characters which will end up being this message. So we can now send it down, so r equals 10, we can send that down. So you can see now it's picking out each of the individual characters and adding those to our message. We need to use our ampersand character, and then we will put in our green equals 20, and then we can put in our b equals 30. So that is our full sort of message coming down. So you can see now it's buffering up those characters. So we need to simply send it our end of frame character, and at that point it should trigger it saying, I've just received a full message, let's go and see if we can make that make sense of that. So we do that. So we can see that we've now said it's received the message complete, it's stripped off the last character to leave us with this full message, and then it's parsed that down into 10, 20 and 30 as our color values. And if you have a look at the LED strip, you'll see that that is actually showing that value. And at this point then, of course, it's now waiting for the next message coming through. So if I send in just random characters, we can see that nothing happens at all. So we can now start sending it a start character. So we can see that it's now synchronizing with that message start. But now if I just send characters in, so there's 10 characters going through, and it's received those, it's building up our message. That's another 10 characters. It's now received 20 characters coming through. And we've said that if we receive more than 20 characters, at that point, something has gone wrong, and we should just simply now exit out of that. So if I put in just one more character through, we can see there that it said, okay, I received this string of data. That was too many characters before the end of message token should have been seen. So I've just come out of there, and I'm now just waiting now for a start signal to come through. So I'm just ignoring everything until you tell me a new message is starting. So of course we can go back in, we can send that in, our message is starting. We could say r equals 10. We could then do some erroneous data. So say we got some garbled data coming through, and we got our finish character. You can see there that it has now got our characters coming through. It's picked up the end of frame character, but then of course this particular message here, it wasn't able to parse that correctly, so it's just ignored that, and it's gone back now to waiting for our start character. So we can come back in here, we can now do our start character, so r equals 100. If I do too bright, it just bleeds out the camera. So let me just do that at 50, and g equals 0, and b equals 50, and our end of frame character. And we should now find that that does it, and we have a nice magenta pixel display. So we now know that our Arduino end of the software is working. So if we can actually get these messages coming down as a data stream through our Bluetooth, it should be able to pick those up and then handle them and display our colors. So I'm just going to simply come back into my Arduino, and anywhere where we've been using the serial channel, if you look up here, I've created a variable up here which is BT serial, and that is connected then to our Bluetooth module. So I simply need to come in here and put BT in front of each of these, and that should then be all ready to work with our Bluetooth channel. Okay, so that should all be ready now to work with our Bluetooth. Again, these print line ones here obviously are sending the data back up to our serial monitor so we can actually see if everything's working okay. Right, so we're ready to start and finally get on to the app on our mobile phone. So let's jump across to the App Inventor and I'll show you how to get that all set up. To use the MIT App Inventor, you need to go to the website, so appinventor.mit.edu. And there's a button that says Create Apps. When you first click on that, it will ask you to log in with your Google account. So if you haven't got a Google account, you will need to create one. But you need to go through that process, sign in, and then you will get into the main App Inventor software. So once you've logged in, you'll be met with this initial startup screen, which is asking you then to set up and connect your device. So whether you have an Android phone or an iOS device, we do click on this same button. And really what that's saying now is we need to download what they call a companion app. That there are other ways of doing it using your computer, but really you do want to have a mobile device, either some sort of iOS device or some sort of Android device. And you'll need to download their companion app. And really the way the system works is that we'll be designing and laying out our app using their browser-based designer software. We'll then connect that to your mobile phone through this companion app, and that will allow the designer running in the browser to download the current app onto your phone so you can then test it as a proper mobile app. And that is the best way of doing that. So there are other ways of doing it, but really this is the most authentic way of getting an app running. So do make sure you go through the process of installing the correct app on your device. Any setup instructions that gives you, please do follow those. And at that point, we then should be ready to start building apps. So once you've gone through that process, we go back into the MIT App Inventor, and either it will automatically have opened up a new project for you, or you'll need to go in here and start a new project. And we're going to give this a name then. So we're going to do this as our Bluetooth test. And I'm going to say OK for that. And then I'm just simply going to open that up. And we're now programming our app. The first thing we need to be able to do is to scan for devices and then connect to the Bluetooth module on our Arduino. To do that, we need to have our app Bluetooth enabled. So if we scroll down a bit here, you'll see there's lots of different blocks that we can add. So if we go into the connectivity, one of the blocks we can add is a Bluetooth client. So to add that, we just simply bring it across and drop it onto our screen. Now the Bluetooth client isn't something which actually appears on screen. It's sort of a behind the scenes object which we can then use in our block programming. But if we highlight that, you'll see any object we highlight lets us then edit its properties over here. So the properties for our Bluetooth client, there isn't anything we need to set up there. That is all set up ready to go. But we can then alter its name. So in this list of components, we can say that we've got Bluetooth client here. If we just rename that, let's just call that BT client, just so it's a nicer name for us. Again, these names, when we come to do our block programming, we will need to call these objects by name. So we need to make something sensible so we know which one's which. So that's basically enabled Bluetooth on our app. And we can now use that to scan for devices. So what we want to have is a button here which lets us call up a list of devices. Then once we select a device, we'll connect to it, and then we'll have a little status message beside that which will tell us whether we're connected or not, and if we're connected, which one we're connected to. The way in which we create our app is very much we will add the components into our screen first, and then we will go and do the code behind it using our block programming system. So we want two objects side by side, so we need to create a layout and a horizontal arrangement, and that lets us put things side by side. So we have a horizontal arrangement here, and again we can rename that. So this is so I usually have the first couple of letters tell me what type of object this, and this is our scan for devices area. And again, you don't have to do that, but that just lets me see that I know which area this particular one is. So we've now got that selected. So we look at its properties. So we want things to be aligned to the left of the screen. We want our objects lining up on the center line. We want our height to automatically match what we put in there. Our width then, we want that to fill the width of the screen. And we want this to be visible. So that's created now our horizontal arrangement. We now need to put some user interface objects in there. So we want to be able to pick from a list. So that's called a list picker. So we simply just drop it into our horizontal area, and you can see the height now has adjusted itself to just fit our button. We then want to have a label, so any text we want on the screen will come in as a label. And you can see they're now aligning vertically, so we've got them nicely centered on that vertical axis. So let's look at our button here. So again, it's got a list picker label here, and we want to just rename that. So let's rename that. So this is a list picker object, and it is the scan. So let's do that. The scan button then, we want it enabled, and we really want then just to come down here and change the text that appears on it. So let's just say scan for device. So there we have our list picker object defined now in our user interface. Our text label then, if we select that, again you can see it's got just a generic name at the moment. So if I rename that, so that's going to be a label, and that is our connection status. I'll do that. Looking at its properties, so initially when we come in and start the app, this is going to be not connected, and I'll have that text in red. So there we have our first block of user interface objects, and that's all ready now for some programming. So if we head over to our block programming area, we have our block coding area here, and then all of the various tasks that we can do over on this side here. And again, some relate to specific objects which we have in our system. So if I click on my list picker for the scan, you'll see it gives me a list of features that has. And up the top here we have these when event actions. So we're saying here, so when the list picker has been activated, but before we actually pick anything, and this is what we want to do. So we want to, when the person clicks on the button, but before they start picking things, we want to load a list of available devices. So let's select that one. So we then want to put a list of available devices into our list picker. So again, we're going to go on our list picker. And if we come down here, we want to set the elements. So we'll click on that one. And if I then snap it into there, so when the list picker is activated, but before people have picked it, we're going to set its elements to, and then we're going to get a list of devices from our Bluetooth client. So in our Bluetooth client here, if we come down, we'll see one of the options is that we can get a list of the Bluetooth client addresses and names, and that's what we need to be able to select one. So if I snap that in there, so we'll click the button, it will instantly go off, ask the Bluetooth client what devices are connected, load those into the list object, and then display the list. So we've actually got enough now to do some testing. We should be able to get a list of clients. To test our app, we need to connect our development system here to our mobile device. And remember, we installed the companion app, the MIT App Inventor companion app. This is how we do it. So if we go up to connect here, we can see that we can connect to our AI companion. So if I select that, the website here will display a QR code, and this is going to be our connection data. So if I go across to my phone and I start up our companion app, we can see initially it says here we need to scan in a QR code. So if I select scan QR code, I then need to go and actually scan that code on screen. And once I do that, we will find that the two things will connect up. So on the screen there it's connected up, and now it has sent down a version of my test app. So you can see here we have our button and we have our bit of text. So I should be able to, but first of all, actually before we do that, do make sure that you have gone through the process in the previous videos and actually paired your mobile device with the Bluetooth module. Remember, the Bluetooth module will not appear in your list of available devices unless it has been paired with your mobile phone. And again, that's the process I showed you how to do in the previous lessons. But once you've done that then, if I click on this Scan for Device button, it should bring up a list of all the devices on my Bluetooth network here. And again, we've got the one labelled My Project. And again, in one of the previous videos on using the AT commands, I showed you how to set up the actual Bluetooth module and set its broadcast name to something specific to your project. So we've now got it scanning the devices, and I should then be able to select that. But of course, it doesn't do anything. We haven't actually programmed what it does when you select a device. So let's go through and then start putting in some more of that code. We now need to pick up that selected object and connect to it. So in our list picker, we've got an after picking event. So if we select that and bring that down here. So after we've picked something, we now want to connect our Bluetooth module to that. So we need to check first of all to see if we can connect or not. So we want to do some control. So we will want an if then else block. So we're basically going to say if we can connect to that device, then we're going to connect to it, else we're going to display an error. So to connect to it, we're going to go into our Bluetooth client and we're going to call our connect function. So we're somewhere down here, we're up the top. Right, so we're going to call the Bluetooth client and try to connect to the address which the person has just selected. So we're doing that. And the selection then is from our list picker, and that's going to be our selected element. So we're looking for selection, LP scan, wrong one, sorry. LP scan, selection. Okay, so our user gets a list of objects, they select one, we then pick out the one they have selected. That has got the address of the Bluetooth object we want to connect to, and we ask the Bluetooth client to connect to that. So if this returns a true value, in other words, it was able to connect, then we want to go in here and actually set that all up on our system. Otherwise, we're going to then obviously say the error. So inside our system then, we wanted to display on that little, if I go back to our designer, we wanted to display in this little label here, which was label connection status, the actual message. Okay, so we will want to, in our label connection status, we want to set its text. So set label connection status text. So if I drop it here and then snap it into there. And we want to then make up a little string. So if I go to my text and I want to join some bits of string together, so join. And again, these blocks, you just have to get used to where they are and how they work. So we want to join in a piece of text. So let's get a piece of text. And the text we want to say is connected to, and then joining onto that then, we want to get the selected value from this list again. So if I do this one here, and we want to find the selected value, IP selection, and there. So that should then set that text to that. We then want to set the text color. So we go back to our label again, and we want to set the text color, set text color in there, and we want to select it then to green. Okay, so that should then connect. If we get an error then, we really want to do exactly the same thing. So if I say that and that, so we should be able to copy that, duplicate that, and drop it in here. So we want to take off that, and we want to set the text to, if I take that off, just to failed to connect. So connection failed. And again, we want to do that one and set a new text color to red. And red. Okay. So that should let us select an object and then try to connect to it. So let's see if that works. So again, my companion app should already be connected. So if I refresh my companion screen, that just makes sure I've got the latest version of the software sent down to it. So if I now go through and do my scan, I should be able to select my project, and we should find that it then connects to our Bluetooth module. And there we go. So our Bluetooth module is now connected, and as it says up here, we have connected to my project. So we're pretty much ready to send some color messages down to our Arduino and see if we can get those LEDs turning on. So if we go back into our designer, what we'll do is we'll create a little button here which will just simply send one specific color down. So if I bring a button in, so let's again rename that button. So we're going to call this button send color, and OK that, and then just set the text on it to send a color. Okay, so that's got a button on the screen. So we now need to activate some code with that button. We go back into blocks. So let's just come down a little bit on here, give some space. So there's our button object there. And we want to say when our button is clicked. So when we click our button send color. Well, what we actually want to do now is we want to call a little function which will actually send the color down to us. We could do it all inside here, but again, we're going to want to be calling this send color at different times in our code. So it makes sense then to put it into its own little function, or they're called procedures in this block language. So if we make a procedure over here, and let's call this procedure send color. Okay, so we now have that procedure. So when our button is clicked, if we come into procedures, we will call send color. Inside our function, we'll want to do a couple of things. We first of all need to check that we do still have a Bluetooth connection. You're probably aware that every now and again Bluetooth devices can just drop their connection. So if we have a connection, we can send the message. If we don't have a connection, we'll need to report that our connection has failed, and we need to let the system reset itself. So if we do some control here, so we want to do an if then else block. So if our Bluetooth connection is connected, so we go to our Bluetooth client. So if our Bluetooth connection is connected, so if Bluetooth client is connected, so we have a connection, at that point we're going to go into our Bluetooth client and we're going to send a text message. So if we call our Bluetooth client send text, and then in here we need to put some text in. So let's put some text in here. And this is our message then. So we have our question mark is our starter frame character. We're then going to send down some red. We're going to then set our green and our blue both equal to 0. So we should have some red LEDs. And then of course our end frame character. So that puts us in there. Else, then we're really going to copy what happened up here. So if I just click on that duplicate, and that bit duplicate, and drop that in there. Okay, so If we click our button, we call our procedure, check if we've got a connection, send the message, otherwise send an error. Right, so let's check and see if that works. So again, we're all connected up with our AI app, and let's just refresh our companion screen. Now, we've obviously refreshed our companion screen here, but we've still got a Bluetooth connection left over from our last test. So I'm just going to make sure that I power down my Bluetooth module. So I'm unplugging my Arduino and then restarting it back up again. So our Bluetooth module is back into pairing mode. So if we scan for our device and then connect to our Bluetooth module, so we've now got our connection, and we should now be able to click on send color, and that send the information down, and we get some red pixels appearing on our NeoPixels. So that's the basic process of how we get this communication link working. We're going to have a number of other user controls then. So if I go back to our designer, I'm going to put some slider bars on here. And as I move those slider bars, then inside our block code, we're going to detect that change in value, reconstruct a color value, and then send that color down to our Bluetooth module using this function over here. So let me go and put that all in place, and then I'll just quickly take you through how that works. So that's everything in place and connected up. So just to go through it quickly, I've basically used a number of horizontal arrangements here to hold the user interface elements in place. So we just create a little space at the top here, and again you can set the height of these, so I've just given it a 20 pixel spacer there. I then got 3 sets of these slider controls. So it's a horizontal arrangement. I have a text label here, and again I'm using percentage widths to do the layout here, so that as my mobile screen size changes, the proportions of my layout will stay the same. Okay, so this is known as responsive design from websites. So I've got a 10% width there from this label, and it just has the letter R in it. I then have a slider control, which I've set to 70% width. And again, I've given its color red. So again, you can control the color either side of the slider. And then I've given it also a range of values from 0 to 25. And again, you can have whatever you want there. And again, those are just values that when I send them down to the NeoPixel, that gives me colors that the camera can reasonably well see. And then just a label over the far side here, which we're going to set to be the numeric value of our slider so that we can actually see what we've set on there. And again, I've given that a size of 10%. So we've got 3 of those. Then down the bottom here, I'm using a button control because the button control allows me to set background colors. And all I'm going to do is I'm going to take these 3 red, green and blue values and then set the color of this to match those so we can see what color we should be expecting. So going into the block side of it, we've got our normal bit at the top here, which we had before. And then we've got our sliders. So instead of having a button which we press to send the color down, we're basically setting an event. So when the slider's position has changed, that will create an event. The sliders themselves are based on floating point numbers. So as you slide them, you will get a lot of position changed events. So what I'm doing here is I'm just making sure that I'm only going to send a new color signal whenever the slider position has actually changed to a different value. So I'm looking at what I've put in the right-hand label. So again, we're going to put a number in there. And if the slider position has changed and the rounded value of it is not equal to that number, then obviously we've moved a whole integer value. So all we do then is we reset the text in our label. Okay, so remember that in effect is going to tell us what was the last setting that we sent down as a color. And then we're going to call our send color. And that we repeat that then 3 times. So again, this is just to make sure that we only send our color information when we actually have a real integer change in our slider position. So the send color function then, we've updated that slightly. So this first bit then, we are setting the color of that background, so the button color on that, the background color of it. So we are using our color controls here. We can make a color from a list, and we simply then have to give it red, green and blue values. So again, those red, green and blue need to be in the range sort of 0 to 255. So if we're using 0 to 25 on our sliders, multiplying it by 10 gives us really our 0 to 250, which is good enough. So again, we've got the 3 slider positions that we're using that. Again, we're rounding them to integer values, and that gives us then an RGB color value to set the background color of that button. In our sending the actual message down to our Bluetooth, again, if we have a connection, then we're just simply creating a text message where we're joining a number of strings together. And one of the things that you'll find that a number of these boxes have a set number of sort of nodules you can connect to. So whenever you use the join command, if I go across to text, you'll find it automatically has just 2 positions in it. If you want more slots, in effect, you simply have to click on the little gear icon, and then you can see a little diagram here of what it currently looks like, and we can just drag more string values into there, and you can see that that then lets me have more nodules so I can join more pieces together. So that's just how these controls work. So I've joined a number of pieces of string. So the question mark to start our frame, R equals then the rounded value from our red slider, green, blue, and then our end frame character. So that's the whole code then for controlling the RGB pixels. So let's just see that in action just to make sure it's all working okay. So again, we're making sure that we are in pairing mode. We scan for device, select my project, and we should now be connected. And if we now do our sliders, we can see that we get our red, our green, and our blue colors matching up. So that looks like it's working reasonably well, but actually it's not doing so well. If I bring across my serial monitor just to have a look at what was actually being received by the system. So you can see here the last couple of messages came through fine. So we've got our message starting, our red, green and blue values, message complete, and so on. But if I just scroll up a little bit to where I was moving the slider quite quickly, all of a sudden we'll see that it starts to go a bit wrong. So here we have our message was received here. A new message started. So we've got red, green. We've then got some funny characters coming through. We've got another second message start character, and so on. We've got 2 message start characters, and so on. So this whole thing down here has gone quite badly wrong. So what's actually happened at that point? Well, if we have a look at our code, we can see that we are creating send events each time sliders are changed. So as we move our slider very quickly, what will happen is that we will be calling this send color function a number of times. So our send color function comes through here and actually sends out our text message. So what's really happening, and you can see it with our sliders here, our communications here, you can see that as we get down through a message, partway through one message, we're then starting the next message, and so on. So in effect, what we're doing is we're starting to send some text out. We then recall this function and it sends a second block of text, and the second block of text in effect interrupts the first block of text so that it doesn't get sent fully. And that then obviously causes us to have this funny data being sent across on our screen. So at the moment, our error handling, so remember whenever we first created our receiving code in the Arduino, we were checking for message starts and message ends and then message integrity. So our error checking code is coping with it. But obviously this isn't what we want to be doing. If we were continually sending data too fast, we would never get an actual proper message coming through. So we need to have a think about how we can get around that. The problem we have is basically a data collision. As one slider changes, it sends out a message. And then as the next slider change happens, it tries to send a message too. And if that is sent before the first one has actually been sent, then it sort of overrides it. And we then get this mishmash of part messages being sent and then being overridden by the next message. So to get around that, I'm going to change the system, and I have changed the system, and it's now going to use a polling style send. So our sliders, so when their position changes, instead of them actually sending the message, what they're going to do is they're going to request that the color be sent. So we have a global variable. So in the variables section down here, we can set a global variable. So I created one that says do the sending of colors, and that's initialized to false. And then when any of these position sliders change, they're going to note that change and then ask for the sending color to be done. So they're going to set this global variable to true. I'm then using a timer. So if I come back to my designer, if we go to the sensors block, you'll find a little clock down here. And it comes down as one of the non-visible components. So I've renamed it, and I've set it to set an interval at 100 milliseconds. So every tenth of a second, this timer is going to trigger. And what the timer does, so when the timer triggers, it checks to see if anybody has asked it to send the next color information. If that's true, it will then send the color, remember calling our function down here, and then reset this flag back to false. So one of the sliders changes, it asks for a color to be sent. The next polling interval set by this timer, if a color is being requested, it calls the send color and sends it down, and then waits around for the next time it's asked, but it only ever checks every tenth of a second. And that is enough time then for our message to be sent out through our Bluetooth connection. So if we test this out, we should then find that if we look at the serial monitor, we should be getting whole messages coming through. So let me just get the serial monitor up and running for us. And then go across onto our Arduino and scan for device and my project. And now as I drag the slider around, we should find hopefully that we're getting fairly consistent messages coming through. So you can see here we've got our message there, we've got a full message, and so on. So our system is now a lot more secure in sending complete messages out, and we're not getting any sort of garbled stuff coming through. Again, we still, when we do anything like this, we do still need to make sure that we both frame our data and we validate our data, because there can be times, I'm not sure if I can find any here, there we go, when I don't know what has happened here, but obviously the data transmission between the phone and the Bluetooth module, some of the data has got corrupted. So again, at that point, we can see here it's received this message. So it got the start signal fine, it got the end signal fine, but inside there somewhere, something went wrong. And at that point, that's where our data rejection needs to come into play and sort that out for us. But at least we now have it sending complete messages. It's not trying to send them too fast, so we're not getting messages colliding together. And this is something you have to take into account when you're designing your system and how it works. And this idea of polling, then, we by true virtue of never trying to send a message too fast, we avoid that collision. So that's sending data from the app down to the Arduino cupboard. And as we've seen there, we need to look at ideas of data collision and data speed, doing some polling of our data, and then handling the integrity of our data. So all of that applies as well to sending data from the Arduino up to the app. So that's really what I'm just going to very quickly just go through now. So all I'm doing is I'm just going to send a little heartbeat pulse, which will go from 0 to 1 every second or so. So all I'm doing in my Arduino sketch, I've got a little couple of global variables here, which will tell me when was the last time I sent one of these pulses and what was the value of that pulse. And then down here in my main loop, I'm saying, so if it's 1 second since the last time we ran this, then make a note of the value, change my output value or flip it over, and then just write either a 1 up to my Bluetooth connection. So again, we just do btserial.write, which is very similar, as I said, to the way you would write up to your serial terminal. So we're either writing a character 1 or a character 0, and we're mimicking that on the built-in LED. So if I drop across into our app, all I've done is down the bottom here, just laid out a couple of components. One is a little checkbox, and one is another label, and that's just simply going to tick the box if we get a 1 and blank the box if we get a 0, and of course show us the actual raw data here. I've also added a second timer, and that is our receive timer. So we're going to poll this data. So we're going to basically check every, and what did I set it to if I click on that timer? So every 50 milliseconds, we're going to check if there's any data has been sent from the Arduino and then handle that. Moving over to our blocks then, we're going to create a global variable to keep a track of what data has just been sent from Arduino. Then we have our event timer. So when our timer times out every 50 milliseconds, we check if we've still got a Bluetooth connection. We'll then check to see if we have any data ready to receive. If we do, we will then read that data in and put that into our global variable. So we're then setting our global variable here to the grab hold of 1 byte. In this particular instance, because we are sending only 1 character per second from our Arduino and we're checking every 50 milliseconds, we don't need to worry about there being a buildup of data because we are clearing our buffer every time it comes through. But once we receive that single byte, we will then show that inside our little label on our screen. And we will then check to see whether we've got a 0 or a 1 and set the checkbox status accordingly. So if we have a 0 coming through, we will turn the checkbox off, and if we have a 1 coming through, or anything that's not a 0 to be honest, it will then set it to be true. So let's just quickly see if that's working okay. So we've got everything already connected up and paired, and you can see here we have our built-in LED flashing. Our data then, of course, is matching that coming up from the Arduino, and we should be able to see then that our checkbox and our received character then are matching that as well. So that just very quickly shows you that sending data up from the Arduino up into our app is very easy, and we have to follow just all the same principles that we've just been discussing about for sending data from the app down to the Arduino. The very last thing to consider then is once you've got everything working, so your Arduino all set up and your app all created in this App Inventor, it would be nice to have that available as a native app on your phone rather than always having to go through this companion app system. So if you go up to your build menu, there are a couple of options here for generating an APK file. So that is an installation file which will install the app onto your Android phone. At the time of making this video, I don't think the iOS version was up and running yet. So you can either save it down to your computer and then you can transfer that across to your phone, or you can simply use a QR code to scan it and download the app that way. But either way, you will need to make sure that you have changed the setting on your Android phone to allow it to install non-Google Play Store apps in it. So there's a setting in your settings to allow it to do that. And then just simply open up that APK file and that will install the app as a native app on your phone. So that should allow you to use your mobile phone with an app running on it to communicate and control your Arduino projects. So if you find this useful, please do like and subscribe to the channel. Don't forget to check out the project pages on my website, and I'll put the links in the description down below. And hopefully then I will see you in another video soon. So bye for now. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.